For this example, it is desirous to find the three equations for a mesh current method. So the first thing to do would be to label the mesh currents. We already know that this is I1, so we can label this mesh as I1 going in the same direction. Remember that the outside branch has the same value as the mesh current within it. It's only when you have an element in between two meshes you'll need to sum the current of both meshes to get the actual value of that one. Up here, this is going to be then 8 milli. It's going to stay the same value because the outside current is forced to be 8 milli. And down here, I'm going to label this as I2. So the equations that we can get, we already know this mesh current value of 8 milli. We can write an equation for the current. The current will have the same positive value, so 3IB is going to be equal to the current going in the same direction will be positive. The current going in the opposite will be negative. The I2 current is indeed flowing the same direction, where with I1 being labeled as up will be the opposite direction. So this will be I2 minus I1. Then the other equation, we will need to take a voltage loop. I'm going to label the polarities as I take my voltage loop. This is going to go on top from positive to negative, and then on the bottom it flows in this direction, so it will be positive to negative. So as I take my loop, I'm going to take a loop that goes through the 2K, around the 3K, around the 44 volts. So I'm going to go in this direction. So as I start here, I go through this, I'm going to have a plus 24. I go through this, I'm going to have a plus 8 milli and a minus I2. I go through this, this is going to be a minus I1 and a minus 44. So again, that loop was a plus 24, a minus 2K IB, or I2, and then a plus 2K 8 milli, and then a minus 3K I1, minus 44, and that is all equal to 0. So now I have the top equation has I1, I2, and IB as unknowns. The second one has I1 and I2 as unknowns, so we need a third equation. So IB is located as the current going through the 2K resistor. So we can also write another equation for IB, which is going to be the mesh current going in the same direction will be positive, so it's equal to I2, which is going the same direction, and the 8 milli is going the opposite direction. So I2 minus 8 milli. And this will give us the three equations with three unknowns. To proceed forward, you can set this up in a matrix form and solve it that way, or you can solve one of the equations in terms of the other. IB here is in terms of I2, and so this could be plugged in here, and in one equation with I1 and I2, then one of those could be solved and plugged into this third equation, and therefore then it could be solved for the one variable with the one unknown.